Good morning, everyone. My name is Raqeef, and roommates are Stephanie and Shane. Today, we'll be presenting on the topic of destructible objects. We will start on the theory behind destructible objects, the implementation, and the game mechanic that we have come up with. An example of a destructible object that we can see here is the house getting destroyed by the bulldozer. We can also witness what is happening throughout the destruction and what makes it a destruction. So firstly, what defines a destructible object? Well, the Oxford English Dictionary defines it as an object that has the capability of being destroyed in the context of a video game. In this case, being destroyed refers to being so badly damaged that its physical shape changes and it's unable to live up to its functionality. There are two major steps when it comes to collision. The first is a collision detection, and the second is a collision resolution. So when a collision of high enough force is detected, there needs to be a collision resolution. Thus, the collision resolution is just how the object responds to the collision after it detects it and how it would react. In this example, the object will break down into realistic pieces following the impact to simulate real-life physics. So now we ask, on the topic of destructible objects, what questions or problems do we have to solve? So first, how do we make the object getting destroyed look realistic? And how do we define what is the process of being destroyed and what makes it realistic? How do we break the object down into what would be lifelike pieces? What amount of explosive force should be added to the impact to make the pieces explode outwards just right and thus look realistic? So in all of this, we need to ask what defines the word realistic? And finally, how can we make the pieces flying away from the impact randomized and simulate what would be real life physics? So all these questions have realistic added into it. So we need to define what is realistic. So for the second question, we'll be using two objects that are having a rigid body and will be colliding with each other at higher speeds. So it makes sense for us to use a continuous dynamic as the collision detection mode for our destructible object. Last but not least, it is not as important as a question, but it is important to know how can we make the runtime for our destructible object faster, more computationally faster, and more efficient. So for the game objects required, we'll require two. They will look the same, but they represent two different states. So there'll be two different game objects that look aesthetically and physically the same. However, they represent a broken state and a normal state. So the first object will be broken up into different and random pieces that will make up the whole object. Other than the second object being broken, the two objects should be physically indistinguishable. It acts as the same object but with two different states, a broken state and a normal state. The object in its normal state will replace the object in its broken state uh, when a collision of high enough force is detected. So on to the next point for components. For components that will be required, a rigid body is a must. The rigid body is responsible for allowing us to manipulate the position of the object under Unity's physics engine. We will also be able to add force to the game object through the rigid body. There will be components that are added by default through Unity, such as the transform and the mesh renderer. The mesh renderer and the mesh filter will be working together to refer to a mesh and render said mesh into the game scene. This is what creates a physical shape for it to detect. And it also works with a collider component, which I'll talk about now. The collider component is necessary to give a physical shape to the object so that it can detect collisions precisely. For the object in its broken state, a mesh collider would be more suitable as it would be more accurate for collision detection than its primitive counterparts such as the cube, the sphere, or the capsule. So this would give a more accurate shape to the object or to be used for collision detection. Last but not least, a script will be required to tell our game object how to behave and how they interact with one another. This is the core building block of all Unity projects. Following that, the physics that will be required to be involved will be forces, collisions, gravity, and rigid bodies. The rigid body is required to manipulate the object through Unity's physics engine, as we just said. And the physics behind the collisions has to be precise to realistically simulate what would happen in an actual impact between the objects. Force, however, is compulsory to move the objects towards each other and how they would and find out how they would react with one another when a collision would change its magnitude and velocity. The physics for force and collisions will work together to achieve an accurate collision resolution that will be comparable to real-life physics. Gravity physics will also be important, as its main role and responsibility is to simulate how the object should descend towards the ground after the initial impact. So as the impact happens, it will go up to the sky and explode and slowly descend. It will also be necessary if the object is meant to drop onto the plane and collide with the plane as the collision. So now I will move on to Shane to speak about the implementation.
So this is the implementation for the destructible object. So for our case, in the destructible object, we'll be using cell fracture. Cell fracture is a feature in Blender which breaks down an object depending on what the user needs. The way it breaks down the object is taking in values and randomly breaking down, cutting the object. So the source limit in the point source is used to run through how many times an object should break, how many times the object can break rather. So for example, a cube, it can only break up to 4 times. So a singular cube can only be broken down to 8 cubes maximum. If the source limit is higher than 8, it will it will stop at 8. So if it's set to 100, it will not go any further. For the noise, the lower the level, the more even the pieces will be. This as the noise level goes up, it will be more random. So for the recursive shatter, recursion value is set to break down an object even further. So depending on how many times you want each individual uh, pieces to be shattered, the recursion value can be adjusted. And to adjust where does the recursive shattering happens, there are three options. The first option is the small option, which is used to target only the smallest of pieces, whereas the big option is to use the bigger pieces and break them down. The random option only does not discriminate against all the pieces. It will randomly break them down. So for the implementation demo, there is two parts to it. On the left, there's the gravity destruction. So when the cube falls, it will shatter and break upon impacting the floor. Whereas the impact destruction, the cubes will only break when the sphere collides with them with enough force. So this is the demo. So the cube will break upon impact, whereas the sphere will whereas the cube will only break when the sphere collides. So this is the overview of the code that we used for the breakable object. And I'll go in depth now. So these are the declared variable that we are using. So the first three variables are serialized. It's used for debugging and to adjust each game object's value depending on what the user wants. We'll go in depth in that later. So this function is taken from the Unity built-in function on collision enter. It collects the collision information, which is used to run the calculations. The if statement is to check if the object has already been broken. So if the cube has already been broken once, it will not break again. If it's already broken, it will return and stop the function. If the speed of the collision is greater or equals to than the break force, it will continue the rest of the script. But if it's not enough, if the speed of the collision is not enough to overcome the brake force, it will not affect the object. This is to prevent any impacts or force that's lower than the brake force to affect the object. This is important as, for example, a glass bottle, it will not it will shatter upon you dropping off a table, whereas a cinder block will not. So for this variable replacement, we allowed it to instantiate the broken state of the object, use and set it to the object's position and rotation. This to ensure that there will be a smooth transition between the non-broken and the broken object. So for each statement, it runs through every single object's rigid body, the broken state, the object's broken state, rigid body. And for this explosion force, it's used to simulate how an object would shatter. So it takes in the collision velocity magnitude, which is the speed. This is uh, the purpose of using the speed of the collision is to scale the force depending on how depending on the speed of it. If the speed increases, the total force will also increase. It will be multiplied by a collision multiplier, which is used to simulate the object's material. So, for example, again, the glass bottle. A glass bottle will have a high collision multiplier. This is to simulate glass bottle shattering everywhere. So it simulates real life physics. Whereas compared to like a cinder block, it will have a low collision multiplier, as realistic physics, it will crumble instead of shatter everywhere. For the collision contact point, we use that to ensure that the source of the explosion force comes from the contact point of the collision. Then finally, at the end of all of this, we'll destroy the game object, so it smoothly transition from the unbroken game object to the broken. I'll pass the time now to Stephanie, which will explain the game mechanics.
So I'll be going through the game mechanic that we have come up with using this technique for destructible objects. So the objective of this game is to find the rat that is hiding inside in the walls. So as the player progresses, the area will get bigger and bigger. So the destructible objects here will be the wall and the fingers on the left hand. So the hand allows the players to slap against the wall to detect like any sound inside the wall within a radius around the hand's position. So for each slap, the finger will break off. So on the right, the fist will allow the players to punch the wall, breaking a hole in it. So the force applied by the fist against the wall will be constant. So here you can see like the wall is made up of multiple cubes of different sizes, individually attached with rigid bodies and box colliders. So upon impact with the fist, the collided cube will be destroyed and replaced with a self-fractured cube. So as Shane has mentioned, self-fracture actually breaks down an object by randomly cutting it to be used to replace the pristine object. So here the self-fractured cube is a cube that has already been randomly sectioned into different parts. So upon impact, the different object parts will react accordingly and explode outwards, which in this case is the debris on the floor, as you can see here. So broken pieces of the wall. So the force applied by the punch against the wall will actually destroy a part of the wall where the size of the hole depends on where the punch strikes at. So I will show you an example on the next slide. So here you can see when the punch strikes in between two cubes, both of the cubes will break into pieces, causing a bigger hole in the wall compared to when the punch strikes in an area that only has one cube. So the left hand, which will be used to slap against the wall, will actually break a finger each time it collides with the wall. So when it comes to the fist, you would naturally think that when colliding against the wall, it will break a hole. So however, for the left hand, we do not want the wall to break when scanning for any sound inside of the walls. So how do we limit this action? We will set the condition to only when the fist collides with the wall, and only then will it break. So previously, I did mention that the wall is made out of cubes that will be destroyed and replaced with self-fractured cubes upon impact. So in this case, it will use the same technique. So upon impact with the wall, the hand will be replaced with a broken hand that has a missing finger. So if I slap against the wall, the finger will be gone and it will be replaced with this object instead. So this happens every slap until the hand has no more fingers left. So for each slap, a sound reader will be displayed, as you can see there, the yellow circle. It will be displayed and it will scan for any sound detected within the walls according to the hand's position. So whenever sound is detected, it will alert the player of the generic area of where the sound is coming from the radar. So now I will show you a demo of the game mechanic. So this is the selection page where the player chooses which hand to use first. So I will be selecting the fist. I will click on the fist and drag the fist to the area where I would like to punch and create a hole. So when I punch, you can see that the broken hole is quite big, which may mean that I have either destroyed a large or combined part of the wall. So earlier I have explained that the wall is made up of different sizes of cubes. So if I punched a big sized cube, it will mean that the cube will break accordingly to the size. Or I may have punched in between two cubes, which may mean that both cubes have been destroyed. So in this case, I have not found the rat yet. So I will drag the fist to another area and break another part of the wall. So now that I have found the rat and completed the objective of the game, I will now review what the left hand actually does. So here I'll select the left hand and slap it against the wall. So as you can see, the finger broke off upon impact with the wall. So the sound reader did not indicate any sound inside the walls. So I'll move the hand to a different location. So then I will slap against the wall again, and another finger will break off. Now this time, the sound reader actually picked up a sound and have alerted me the general area of where the sound is coming from. So since I have already found the general area of where the rats could be, I'll switch my hand to the fist. I can see that the left hand still has two fingers missing. So I'll take the fist and drag it to the area where the radar have alerted me, and then I'll punch a hole in the wall. So yay, now we have found the rats in the wall and completed the objective. So now that we have gone through the theory behind destructible objects and how it can be implemented through cell fragments, we are able to come up with a game idea that utilizes the game mechanic that we have devised. Thank you for your time.